Okay, section 4.2, even more on area. Alright, so what we've been doing, that if I had a general function here and I wanted to go from some A to some B and find this area under here, here's f of x. What we've done is we've said, hey, we can break this up into n equally sized pieces. Well, in general, how big are those, and what might we call them? And what we'll do is we'll call this distance here delta x, a change in x, and I can get that delta x simply by, if I know there are n rectangles, delta x is b minus a over n. So there is the width of each of these things, b minus a over n. And then for the heights, what we've been doing is we've been taking the smallest rectangle. Okay, so our smallest rectangle. Now, the way we've been getting that is we've found the minimum of f of x on the interval, well, if we call that x0, x1, and so forth up to xn, the minimum f of x on any given rectangle. So some x, we'll call it xi to xi plus 1. Okay, so the smallest rectangle on each part, we've been doing that. And, what we could do is, let's see, I'm trying to remember if your book has I think they use little m's, yeah. So they're going to call that minimum at x sub little m, okay? So that value is f of x sub little m, and what we know is that, xi, for that particular m, I, yeah, I should have an I on there, so a double subscript, x sub I is less than or equal to m sub I less than or equal to x sub I plus 1. Oops, sorry about that. We have something like that, and then the largest rectangle has our maximum f of x on that interval, so on xi to xi plus 1, and oops, and so your textbook is and actually, now that I'm thinking about your textbook, probably what we should do is, instead of doing xi plus 1, we should probably do xi minus 1. So this is on xi minus 1 to xi, and change that to a minus 1 and that just to an xi. Okay, so our mi's would start at 1, m sub 1, and go up to m sub n, the way, so they kind of match up with interval number there. Okay, and so that they're going to call f of x sub uppercase m sub I, and so we have x sub I minus 1, oops, forgot my x there, is less than or equal to x sub uppercase m sub I less than x sub I. Okay, so yeah, back there I forgot my x. Okay, so then if we have that, what we would say is the sum, and here in both of these we can start I at 1 because we're talking about the m's here. So 1 to n. We're going to take f of x sub small m sub I times our delta x in general. And then that's less than or equal to the area, which is less than or equal to the upper sum, I equal 1 to n of f of x sub uppercase m sub I delta x. Okay, so that is what we can do to bound the area. Okay, we'll call that one good.